Hello everybody, and welcome to the Unit 2 Factors Affecting Solution Formation Chemistry Lab. This is for honors, this is for core, comprehensive if you have one. I don't know if comprehensive chemistry has one, but honors chemistry and core chemistry does have this lab. So basically it's going to be helping you out. And for me, I think it was pretty difficult. I mean, it wasn't difficult, but it was like, a little confusing to start off at first because there's no material telling you, oh, you do this and it'll be okay. So if you need any help, this is the video to watch because I'm going to explain thoroughly in a few minutes on how you can do this lab in the right way and get an A grade on it. So basically, this lab is talking about a few things. Some of the main things that it is trying to say, let me just bring up my pen, is what it's all about. So I wanted to make an illustration for you, which I did over here, which tells you exactly what is going to happen. So basically, we're taking 3 vials, which are like tubes, and basically 6 tubes, and we're going to be doing 2 different sort of experiments on them. So we basically have 3 different forms of salt. We have a pellet, we have coarse, and we have fine-grained. This is a pellet, this is coarse, and this is fine-grained. So if you see the difference between all of them, one is really large, and then it gets smaller and smaller as you go. So it's asking us to put each of them in different temperatures each, hot, cold, and room temperature, and then seeing the comparing contrast of 3 vials being agitated and 3 not being agitated. So that's what we're going to be doing this experiment. And agitated basically means stirring it. So to give you a better example again, stirring it basically like you put the salt in and you have one that you have stirred and the other you haven't stirred. So again, go back to your lab report, open it up, go on the first question. It asks you compare and contrast the rate of solution formation between 3 physical forms of salt that were placed in the vial and not agitated versus the 3 that were agitated. So keep this in mind. Okay, this is a great visual representation of what I'm trying to talk about. So keep this in mind. You should be good to go. Now to give you a better example again, let's go here. So think of it like having coffee. I don't know if you guys use sachets, because a sachet, you just kind of put it inside and you just mix it up and stir it up and then you get it. So imagine that we used a sachet, or even if you just used fine-grained coffee and you just put it into hot water. So it kind of, for me, I know that it ends up like a lump when you put it into the not agitated versus when you actually do agitate it, like when you mix it up basically you can use a foamer or whatever you use. That is agitated. This one gives you a great cup of coffee, but this doesn't. So to help you out again, just think about coffee. I know it doesn't really go well with the 3 types of salt that we have, but it gives you a representation in your mind. Okay, this is what it's talking about. So imagine just pouring in with be it a spoon or a sachet of coffee, and you just leave it there in the hot water. It's after a while. Now I'm talking about hot water. After a while, it will end up being dissolved, like after maybe a couple of hours, because it is hot water after all. But you'll notice that hot water, in any way, hot actually does equal to a faster rate of dissolving. So keep this in mind for the first and second question, okay? I'm giving you hints here and there. Write them down and think about them. So if it were cold water, obviously there'll be nothing happening, if you don't agitate it. If you do agitate it, it won't taste very good. Anyway, so in cold or room temperature water, it's not going to do a great job. Again, hot temperature does in fact it actually does something when it comes to how fast it can dissolve into the water. So for the first question, the first 3 that were not agitated, think about this. The first 3 that were not agitated at all, like you didn't touch them, you didn't stir them, you didn't move the place around. What happens? Even just thinking about it, and not even doing it, but just thinking about it in chemistry-wise, nothing's going to happen. It's going to take a long time for it to dissolve. In the hot water, it actually does go a lot faster. But if you don't stir something, it's not gonna cook itself, it's not gonna do anything, right? And the ones that were agitated, think about that. It would be a lot faster. Do you think it'll make a great cup of coffee and it will stir it up? And when you stir it up, you'll have few of them will dissolve faster, and the rates are all different, of course. I'm sure the pellet will take a lot longer because it has to break down a lot more. But the fine grained one would take a lot less time because it's already fine grained. So, see what I'm talking about? Alright, going next, this is basically what I'm talking about. The not agitated response is again faster if you have hot temperatures. So hot, anything that's an increase in hot temperatures is still faster. So this is an example again of the coffee. This is the not agitated. It'll be like this. It'll be like okay, but this here, the agitated, will be a lot better. See the results here? This is a great representation. This is again in hot water, and in cold water, I'm pretty sure if I can just do it here. For cold water, let's have two different mugs. It look terrible, but for cold, they're both cold again. Okay, so this is not so cold. We've got our pellet. So I'm pretty sure our pellet for the cold will stay there for like 5 days or something like that. And for the agitated, it will take a lot faster, but it'll still be lumpy. It's not going to be fully mixed in until another couple of days, right? So this is the not agitated, and this is the agitated. So yeah, there you go. That gives you an example. Now, I did give you a hint for the second question. So this is the first question. I just explained this to you. For the second question, you want to think about the temperature. So going back to the coffee, I'll just explain it to you in like a few small seconds. So better hear me out because I won't be writing everything down. So temperature of the solvents and the rate of the solution formation has a very important relationship in this lab. Agitation was only one part of how faster or slower the solvent dissolves. So when you get an increase in temperatures, let's say you get an increase in temperature, you will get an increase of the formation of whatever. So say you put in that lump, it would end up being dissolved after a few days or a few hours because it's hot water. If it's cold again, will it do the same thing? I don't think so. So it will do it a lot faster, except it will take time because again, I haven't stirred it up. But when I have stirred it up, here's the versus part. When I have stirred it up and I have agitated it, it will completely dissolve. So it'll actually be fully dissolved in there. You won't be able to see any sort of bits and particles at all. The hotter the temperature, though, the hotter the temperature, and in this case we have water, the hotter the water is, the hotter and the faster the solute or the salt dissolves. Okay? So it turns out it was definitely a lot faster than the other two, like cold and room temperature. Hot water will be a lot faster. So again, this is really important to note down. Alright, so for our next one, we're talking about the last question, which is collision theory. So, to explain this to you in a better way, if you go and Google collision theory, it's basically the chemical reaction, chemical reaction to occur, the reacting particles must in fact collide. So it's basically talking about the more you collide, your results are going to happen. The less collision, so see there's less collision over here, low concentration, few collisions. So the salt in the vial that is not being agitated, there's very low outcomes for that. And the high, so like when you stir it up, what's going to happen? It's going to be a lot faster. It's going to be, you'll see a lot more results in that sense. So the rate depends on frequency of collisions, which is also an element in this lab. The vials that did not have agitation occurring in them did not have many particles colliding because we didn't stir them up. They were just sitting there, they're just sitting there. However, the vials that had constant agitation in them had particles that were being frequently hit, which resulted in the salt dissolving until even a speck was not seen. So, agitation is basically constant stirring. So, when now putting this all together, everything from this lab, the agitation, which was constant stirring, also provides sufficient energy in which the particles collided. So when you have agitation, that equals energy, and that equals collision, which equals salt being fully dissolved. So I hope this helped you in your lab. And if you have any questions, again, go up to the website. It has a lot of information. I have a lot of PowerPoints up there, so check those out. But these 10 minutes should have helped you, and I hope this did. Have an awesome day, and see you soon.